Hey guys, welcome back to my channel. So today what we are going to see is uh, in case if you are doing a numerical study in any research domain, so what you need is actually you need to first perform the validation of your model with already published similar kind of model or uh, results, okay, which is already being published. So in that case, suppose in the experimental studies they are going to do in the research paper, so they will always have certain graphs or the results that they have obtained while doing the experimental study. So in this paper, which you are going to, which I am just showing here, fire resistance of partially encased steel columns with restrained thermal elongation. So in this paper, they have done experimental study here. So this is the entire experimental setup, the test setup, and basically they are considering a partially encased column. They are conducting a thermomechanical analysis of this composite column. So these are all the considerations they have made, and this is the cross sections of the test columns. So CSS 200 and CSS 160. You need not worry about that. What is that? So these are different locations. So let's keep all these things, and these are the experimental test specimens and the number which they have specified. So after doing those things, the first result what they have called is the temperature distribution. So you can see the evolution of temperatures in cross section S3 of column. So this is the S3 is the this location at the mid space, like is almost 1.47 meter from the top. Okay, so at that location they have obtained these results. Okay, so the results is like the time in the x-axis in minutes and the temperature in degree Celsius in the y-axis. So this is the graph actually. So for there are six probe locations. One one E11, 12, 13, 14, 15, and 28. So which have been located here. So you whenever you want to validate a model, so what you have to do is you have to build this model in your own software which you are using, and then try to get the results similar to this uh, graph whatever they have obtained. So very close to these graphs what they have obtained. Then only we can say the validation or whatever my model I constructed or model is being correct and I can do the further parametric studies. So in that case, they will not mention any values here like x and y values in this paper. So what each and every coordinate they got it. So that is it becomes very difficult for us, the researchers, like to know at what point what all the values they have got. For example, I need for 10 minutes, what are the values at the different locations. So in that case, we are going to use a tool here, so which is free of cost. I'm using a free version, not a paid version. So to obtain the x and y coordinates of all the points which I want for my validation purpose, so there is a software called as a plot digitizer. So I will just show you. So once you type plot digitizer online, so you'll these all things will open. So in that case, just select the plot digitizer online app. Okay, so this will take you to this window. So this is not a pro version which I'm using. So in many videos they guide you on the pro version. So this is a free version. So what you need to do is you need to download this image. You can see there is an option of downloading this image. So I already downloaded it. So I'll just select on this and upload this image 6, and this is what is being uploaded here. So now you can see the entire graph. The image is not so clear, so that is one disadvantage. It's okay, but still we can very nearly get all the points, not a rough thing. It will be very near to accuracy depending on how well you choose the points here. So here you can see uh, On the right side, you can see that wherever you take your mouse cursor, those all points you can be zoomed, and there's a cursor. Okay, there's a cursor here. You can see the cursor, which will have a crosshair. So where you want to target the location in the graph. So x-axis and y-axis. So here, in case if there is a, it is only a linear graph. Since this is a normal linear graph, you can select this as a linear as x and y as linear. Suppose if it is of log type, then you can select the log to the base 10. And there are different options. So let us say if you have date and time. Suppose if you have a date, time and day, time, year, hours, minutes and seconds. So in that case, here also suitably you can select those things. And based on the x and y axis, whatever is already being published in the paper, you can make suitable arrangements. So since this is a linear graph here, so I will just select the linear options on the both sides. So what is the procedure? So the points x1, x2, y1 and y2 are still being located here. So they have not been set to what is required. So which we will be doing shortly now. So now I'll select the linear. Now what I have to do, I have to enter the value of the first x1 coordinate. So you need not enter the 0, 0. So that is origin, quite understood. So you need to enter the value of the first x1 coordinate, which is 10. Okay. So the second x is the last point here. So that is 70. Okay. So similarly, you can enter the y-axis values which start from 100 and the next value is 1000. Okay. So now you can see once you entered these values, you can see that these points are being appearing for. So it means that the graph is ready for you to calibrate. Okay. So what I will do is I will just take this x1 to the point of the 10 which I have located and just drag this x2 to the end point which you have given to the as specified in this right x and y axis. So then it is y1 to 100 and y2 to the 1000. Okay. So now by this you can say that the setting up of this initial setting is done for obtaining the points, and now for 10 minutes let me obtain the point here. So you can see the zoom in and see on the right window where exactly the point is colliding with the axis. So I will select this first point here. So for 20 minutes I'm going to select this point. So for 30, so this, and for 40 minutes. So similarly you do a repeat it till the values that you are having. Okay. So this till here. So now you can copy these values, copy to the clipboard. Now you can see accurately these values are being represented. So this is how you can get the x and y coordinates of the graph points which you want. And you can still, if you have a lot of there are a lot of other curves which you can also accurately get it. So similarly, by repeating the procedure, so you can save this, copy this, save to Excel, and whatever the options are there, you can do them. So I hope you understood how to uh, get the data of the points of an image that is being already published in a research paper. So this will give you an idea. So where I can show you that these values will be helpful for you to plot the graphs. Okay, fine. Thank you. Let us meet in the next video. Bye.